Okay, so guys, in this video we have to find the Taylor series for x power 4 minus 3x square plus 1 at the neighborhood point a is equal to 1. Okay, so let's begin. Let's take the first derivative. Of course, the zero derivative is the same thing, the same function right over here, x4 minus 3x square plus 1. Then the first derivative would be the first of all the power 4, then the function power minus 1, 4 minus 1 is 3, minus 3 as it is because it is a constant, then the derivative of x square. Derivative of x square is 2x, right? Then 2x, the 2 is also a constant, so 2 multiplied by 3 will give us 6. So we will have 6x as the derivative of negative 3x square, plus the derivative of any constant is 0, so that's it. Now the derivative of 4x cube minus 6x. First of all, let's deal with the simple thing right over here. Derivative of negative 6x would be negative 6 because x will be cancelled by the derivative, just like d by dx x. This will be cancelled, we will be left with 1. 1 multiplied by 6 will give us negative 6. The derivative of 4x cube will be 4 will be as it is, then the power, so 3 will be separated, then the function power minus 1, 3 minus 1 is 2, so 4 multiplied by 3 gives us 12x square minus 6. Then the third derivative, the derivative of negative 6 will again be 0 because it is a constant. The derivative of 12x square will be 12 multiplied by 2 will be 24 x square, so 2 minus 1 would be 1. Then the derivative 24x will be 24. And just for your information, the fifth derivative will be equal to 0, and of course the thing over here, when we will put the derivative into the formula, it will be 0. Because it is a degree 4 polynomial, the degree 4 polynomial always has the fifth derivative as 0, okay? And so this is the only case where the Taylor series will be finite, okay? I will tell you what I'm trying to say in a minute. First of all, let's put all of these derivatives into the formula with the value of the neighborhood point as 1. So wherever we are having an x, we can put 1 over there, okay? So if we take the first equation, we have 1 power 4 minus 3 times 1 square plus 1. So if we do the computations, we have 1 minus 3 will give us negative 2, negative 2 plus 1 will give us negative 1. So negative 1 divided by 0 factorial will give us negative 1. Then we can put the value of x as 1, so 4 multiplied by 1 will give us of course 4. Then minus 6 multiplied by 1 give us negative 6. So 4 minus 6 is negative 2 divided by the first factorial. So it will be negative 2. We can put the value of x as 1. So 12 multiplied by 1 will give us 12. Negative 6, there is no x over there, so we cannot put a 1. So of course we will have 12 minus 6. So 12 minus 6 is actually 6 divided by the second factorial. 6 divided by 2 factorial. 2 factorial is actually equal to 2 multiplied by 1. So 6 divided by 2 is equal to 3. We can put the value of x as 1. So 24 divided by the 3 factorial. So 24 divided by 3 factorial is actually equal to 3 multiplied by 2 multiplied by 1. So 3 multiplied by 2 is 6. 24 divided by 6 will equal to 4. Over here we do not have an x, so it would be simply 24 divided by the fourth factorial. Now the fourth factorial is actually equal to 4 multiplied by 3 multiplied by 2 multiplied by 1. So it is 24. 24 divided by 24 will give me 1. And the fifth derivative is of course 0. Let's put all of these things into the Taylor formula. So we will have the function right over here. So x4 minus 3x square plus 1. So the first value, negative 1 plus, we are having a negative sign actually, so we will have negative 2, okay? So we will basically use x minus a. We are trying to write x minus a. Over here we have a as 1. So we will write x minus 1 divided by the first factorial and the first power. Then we have the positive term 3, x minus 1. We have to follow the n values. So the n value would be squared divided by 2 factorial. We have 4. So it will be 4 x minus the value of a, it is 1. Then the value of n, it is 3 divided by the third factorial. Plus we have 1. Then we have x minus 1 power 4 divided by the fourth factorial. You see, we have the 4th degree polynomial and we have the 4th degree final answer for this polynomial. And of course if you put 5 0, we do not have anything, so the series will be finite, okay? So it won't be going on and on. So this is the final Taylor series for this function.